Hi, this is John Kennedy. I'm here with Ed Laura today to talk about migrating file data to AWS. We're going to give you a demo and some technical guidance. We're also going to be talking about a couple of products, AWS Storage Gateway, which is a hybrid cloud storage service that gives you on-premises access to virtually unlimited cloud storage. We're also going to be talking about AWS Data Sync that makes it fast and simple to move large amounts of data online between on-premises storage and Amazon S3, Amazon Elastic File System, and Amazon FSx for Windows File Server. Ed, would you like to say hi?
Hi, this is Ed Laura. I'm a solution architect here at AWS.
Great, thanks. Okay, so today we're going to cover an overview of the cloud adoption journey, an introduction to your cloud storage options, AWS services for migration and hybrid cloud storage, and then we're going to go into a deep dive with Ed, where Ed will take you through an on-premises file server migration using AWS Data Sync and AWS Storage Gateway. So today, you have on-premises data and applications. There are many application workloads on-premises that either can't be moved to the cloud or are difficult to move. Some of the more common application examples include genomic sequencing, media rendering, medical imaging, autonomous vehicles, and many others. Customers are looking to take advantage of the durable low-cost storage that AWS provides and are looking for ways to connect those applications to the cloud. As companies look to move applications to the cloud, many applications will be relatively straightforward to move, but there will be some applications that are not so simple. Apps may need to remain on-prem for performance reasons, compliance reasons, or they may be too complex to easily move into the cloud. Some apps may need to remain on-prem indefinitely, so enterprises will want to explore hybrid cloud storage solutions that provide ready access for on-premise apps to data stored in AWS. Some of the cloud migration storage challenges we see today are that customers have complex on-prem applications and databases, but they really want to leverage cloud resources for cloud scalability. They may also need to access applications locally, but want to take advantage of cloud compute and analytics engines in the cloud. They also have compliance requirements to integrate with enterprise security and management tools, but they want to manage and monitor from a single pane of glass in the cloud. They also need reliable, easy connectivity to the cloud, even when the data is in many locations. Our customers are moving to the cloud to accelerate innovation, untrap their data to drive new insights, achieve higher savings, and reduce their business risks. While many enterprises start their cloud journey by moving individual projects and perhaps claiming they're cloud first for new applications, we've seen that the organizations who are most successful are those that aggressively address the challenges of mass migration early in their journey to achieve cloud advantages such as agility, cost savings, elasticity, faster innovation, and global deployment in minutes. So just to talk very briefly about these stages before we dive into some of our products and architectures. Early in the journey, enterprises are in the project phase, where they're looking to develop brand new business capabilities by taking advantage of cloud native features. Once they've experienced those features, they enter into the foundation stage where they want to scale cloud adoption. This can include creating a landing zone, including for network connectivity and identity management, center of excellence and operations model, security and compliance readiness, all so that they can go into the cloud. And this is actually where we're going to start our demo today, is talking about how they can lay that foundation. After experiencing the foundation stage, they move into the migration stage where they want to migrate applications into the cloud. So initially, while they might be moving storage and accessing it on-prem, at this phase, they're migrating workloads and applications into the cloud where they'll run in cloud. So all of their data and applications are running in cloud. And then during the modernization phase is where organizations tend to recreate their applications with cloud native architectures. Once passing through modernization, we often see organizations go into a reinvention phase where they continually innovate in the cloud, rebuilding their cloud native applications, taking full advantage of the flexibility and elasticity of the cloud. So within those stages of foundation, migration, and modernization, we see Storage Gateway and Data Sync for many use cases for customers, including moving backups to the cloud. That can include file backups, tape backups, and database backups, reducing on-premise storage needs by deploying cloud-backed file shares with Storage Gateway, also giving low latency access for on-premise applications to cloud data using Storage Gateway. For Data Sync, we see customers using the product to migrate active application data to the cloud, also transferring data to the cloud for in-cloud processing, and also archiving data from on-premise to free up on-premise storage capacity. We also see replication for data protection and recovery. Storage Gateway comes in 3 varieties. We're going to specifically focus on File Gateway today, but it's important to know that there are all of these options when you're booting up a Storage Gateway on-premise. The File Gateway presents a file interface that enables you to store files as objects in Amazon S3 using industry standard NFS and SMB protocols, and access those files via NFS and SMB from your data center or Amazon EC2, or even access those files through the S3 API. File Gateway has POSIX-style metadata storage, including ownership, permissions, and timestamps that are durably stored in Amazon S3 in user metadata of the object associated with the file. Once objects are transferred to S3, they can be managed as native S3 objects, and bucket policies such as versioning, lifecycle management, and cross-region replication can be applied to those objects in the bucket. Customers use the File Gateway to store file data into S3 for use by object-based workloads, including data analytics or machine learning, as a cost-effective storage target for backups and as a repository or a tier in the cloud for application file storage. All of this without the need to change existing applications. Later in the presentation, we're going to see how you can use File Gateway to replace on-premises storage. The Volume Gateway presents your application's block storage volumes using the iSCSI protocol. Data written to these volumes can be asynchronously backed up as point-in-time snapshots of your volumes and stored in the cloud as Amazon EBS snapshots. You can back up your on-premise Volume Gateway volumes using the service's native snapshot scheduler or the AWS backup service. In both cases, volume backups are stored as Amazon EBS snapshots in AWS. These snapshots are incremental backups that capture only changed blocks. All snapshot storage is also compressed to minimize your storage charges. Tape Gateway presents itself to your existing backup application as an industry standard iSCSI-based virtual tape library, consisting of a virtual media changer and virtual tape drives. You can continue to use your existing backup applications and workflows while writing to nearly limitless collection of virtual tapes. Each virtual tape is stored in Amazon S3. When you no longer require immediate or frequent access to data contained on a virtual tape, you can have your backup application move it from the Storage Gateway virtual tape library into an archive tier that sits on top of Amazon S3 Glacier cloud storage or Amazon S3 Glacier Deep Archive storage, further reducing storage costs. Now I'm going to dive into the architecture of Storage Gateway. You can see on the left, Storage Gateway easily deploys on-premises as a virtual machine. We support all the major hypervisors, including Hyper-V and VMware, and we also deployed a pre-configured hardware appliance. You can get the Dell appliance today on Amazon.com. By providing a local cache, Storage Gateway enables low latency access to frequently accessed data. Storage Gateway supports access via standard storage protocols, including NFS, SMB, iSCSI, and iSCSI Virtual Tape Library for on-prem applications to access data stored in Amazon S3. So essentially no changes to customers' applications. You can actually see this on the left. We have an application server, a user workstation, and a backup server. The application server might be mounting an SMB file share or an NFS file share, and it sees it as it would a regular NAS. Similarly for the user workstation, A workstation or a server may also be mounting a volume over iSCSI, using that volume as they would from a SAN, and then in the cloud, we can take a snapshot of that with a click of a button. So the backup use case here, you can see the backup server connected to our storage gateway that might be connecting and switching its usage from a tape, physical tape device to a tape gateway, and it might be using the iSCSI VTL protocol. It may also be backing up, you may also be backing up an SQL server, and that might be mounting a regular SMB or NFS file share. You can see that the storage gateway then connects in the cloud. You can actually, that connection can actually go over a private link or even a direct connect, but whichever way it connects to the cloud, it's over a secure connection, connecting into a variety of services in the cloud that are integrated with Storage Gateway. For storage, there's Amazon S3 backs all three gateways. We also have Amazon S3 Glacier and Deep Archive for archiving tapes and files. There's also Amazon Elastic Block Store where you can take snapshots of the volumes you've got on a volume gateway. Storage Gateway also integrates with AWS Key Management Service, AWS IAM, CloudTrail, and CloudWatch, allowing you to monitor all of your gateways from the cloud, seeing the statistics of each of your VMs, allowing you to monitor things like CPU usage and memory usage and number of users accessing the storage gateway, all from your cloud interface. Key management service can actually be used to store your encryption keys for encrypting data on-prem and in the cloud. Now we're going to talk about AWS Data Sync. AWS Data Sync allows you to transfer data to the cloud up to 10 times faster than common open source tools using compression and parallel transfer. It's easy to use. It supports NFS and SMB protocols, and it's installed on-premise or in the cloud as a VM, just like Storage Gateway. It's secure and reliable. It encrypts in transit, it encrypts at rest on S3, EFS, FSX, and it has built-in verification. It's cloud integrated. That means that it can actually move to all of those services I mentioned a second ago. It can move data from on-prem to S3, to EFS, to FSX. It's integrated with CloudWatch, IAM, and CloudTrail, just as AWS Storage Gateway is, and it's cost effective. It's only 1.25 cents per gigabyte transferred, and you only pay for the data copied. So let's have a look at the architecture for Data Sync. You can see you have an on-premises file system, could be mounted via NFS or SMB, that you set up as the source for your online data transfer. Then you deploy the agent or agents in your environment to be able to talk directly to those shared file systems and create tasks to do the transfers. The agents talk directly to the cloud over a secure network with many network optimizations, such as parallel streams. You can think of these as lanes on a road. The data is encrypted end to end. You get to choose your destination region and destination type for the cloud data. Data Sync is a fully managed service and supports all S3 storage classes, including Glacier and Deep Archive. It also supports EFS and Amazon FSX for Windows. Let's talk a little bit about those destinations. In a minute, we're going to see a demo where Ed uses Data Sync to move data into S3 that can then be accessed via Storage Gateway. Amazon S3 is an object storage service offering industry-leading scale, availability, security, and performance. It provides 11 nines of durability, covers a wide variety of use cases, and is cost-effective without sacrificing performance by storing data across the S3 storage classes. You can leverage the S3 storage class analysis tool to discover data that should move into a lower cost storage class based on access patterns and set up S3 lifecycle policies or S3 intelligent tiering. Amazon Elastic File System, or Amazon EFS, is designed to provide massively parallel shared access to thousands of Amazon EC2 instances enabling your applications to achieve high levels of aggregate throughput and IOPS with consistent low latencies. Amazon EFS is well suited to support a broad spectrum of use cases, from home directories to business-critical applications. Customers can use EFS to lift and shift existing enterprise applications to AWS Cloud. Other use cases include big data analytics, web serving, and content management, application development and testing, media and entertainment workflows, database backups, and container storage. Amazon FSx for Windows File Server is a fully managed native Microsoft file system available for use with AWS Cloud Services. Full support for SMB protocol is provided, and Windows NTFS, and there is also Microsoft Active Directory integration. Use cases include home directories, media workflows, and business applications. I'm now going to hand over to Ed, who's going to talk a little bit about a customer who actually executed a migration that looked very similar to the demo we're going to perform today.
Thanks, John. So here's an example of a customer that leveraged AWS Data Sync and File Gateway to migrate data into the AWS cloud. Now, Cox Automotive, they're a hosting provider for over 40,000 auto dealership websites. And as part of doing business, they are forced to manage a large database full of millions of images. In order to host these large image repositories, they've over time had to manage stacks of disk arrays on premises, which were of course expensive and took up a significant amount of physical space, power, and cooling. So they were also going through the process of trying to build their own cache hierarchy, which has many applications accessing it all the time via standard NFS protocols. This was extremely time consuming, took up a lot of resources internally, and what they wanted to do was they wanted to get to the cloud. So with so many of these websites and applications needing active access to the data, they couldn't afford a clean cut migration window to actually take the systems down in order to migrate the data. So we worked with them, and then in order to get around this, they were able to use AWS Data Sync to actively transfer millions of images to the cloud, and then use File Gateway to maintain access to those cloud images on premises in their VMware environment via their standard NFS protocols. By moving to the cloud, the engineers were able to spend more time on strategic projects rather than managing physical infrastructure in an ever-growing data set. They were also able to save about 85% on storage costs per locations. AWS Data Sync combined with AWS File Gateway allowed them to leverage virtually unlimited cloud storage, maintain application compatibility with all their legacy homegrown applications that leverage this standard NFS protocols, and spend more time on focusing and modernizing their applications. So now we're going to shift over to the demo. Our goal in this demo is to perform an on-premises NFS file server migration to AWS Storage Gateway, allowing us to retire or sunset the legacy NFS server system. In this example, we have an on-premises VMware environment with a local NFS file server exporting an NFS share that is mounted on a Linux-based application server. We have deployed an AWS Data Sync agent on premises in our VMware environment and an AWS File Gateway, both as virtual machines inside of our VMware cluster. We will walk you through the steps of this migration, resulting in the data being stored in Amazon S3, which is located in our AWS Cloud region, US East 2. Our first step for this migration is to set up a data sync task that will run on our local data sync agent, and when run, we'll copy the data from our NFS server, which is the source, into our S3 bucket, which is the destination. That will get our data into the AWS cloud. Our next step will be to provide access locally to the data that was previously copied into the cloud. We will create an NFS share with AWS Storage Gateway and mount that share on our application server. Now, in a migration scenario, our customers would typically run an initial or seed sync of the data and then perform a final cutover at a later time during a planned maintenance window after proper communication has been sent to all stakeholders. To simulate this, we will rerun the same data sync task that we created previously, which will act as a delta sync to copy over any changes to the data that have occurred during that period of time. Once the delta sync completes, We will then run a refresh cache operation on our newly created file share on Storage Gateway, which will update the local storage gateway with the proper metadata for files that have changed. We will then verify those changes on the NFS application client server and proceed to finalize the cutover. Our final step, once we have verified the data is in sync, is to be able to unmount that original NFS server export on the NFS client application server and point our application traffic over to the new location, which resides on the file gateway. Okay, so for this demo, we will use a Windows remote desktop client to work on an on-premises VMware environment. First, we're going to go to the VMware console, where you can see we are using a VMware cluster with high availability enabled. For this demo, we have set up 4 virtual machines, an AWS Data Sync agent, an AWS Storage Gateway, and then we have our NFS server and an NFS client, which is our application server. Our NFS server is serving out exports. And for this demo, we have created one called Data that includes about 300 files. Each of these folders, project 1, 2, and 3, contain about 100 files each. And we're going to be able to demonstrate how we can exclude certain files like the htaccess file from actually syncing to the cloud and for the transfer onto our new system. To show you what the export looks like, we'll do a sudo export fs-v. You can see we've got data, and that's being exported to our entire local subnet, of which we'll go to our NFS client to view the actual mount point. There's the local IP address of our NFS server in the export. You can see it's about 500 gig and only 1% full. And if we browse to that directory, we'll see that same files. There's our 100 files. And we've got project 1, 2, and 3. So there's our data. Okay, so our first step is to open up the AWS console and browse to Data Sync. Now I've already got an agent created. You'll notice the name, AWS Data Sync Agent 01, which should look familiar as what's in our VMware environment. And what we're going to do is we're going to set up our task to actually copy the data from our source location, which is our NFS server, to the destination location, which is going to be an S3 bucket within the same region. So I'm going to go to tasks. We're going to create a task. Now we haven't created the location yet, so we're going to walk you through creating this location. We're going to choose the type. And here's the types that John was talking about earlier. Our source is going to be NFS. Our agent. Now you can have multiple agents per job as well. But in this case, we're just going to use one. Our NFS server IP address. This is the local address. And the mount path is data. All right, so for the destination type, we're going to choose S3 bucket. We're going to choose an existing S3 bucket, in which case I've created one with the defaults for NFS file server migration for this tech talk. We're going to use the standard storage class in this case, although you do have the option of choosing all the other S3 types. And the folder that we're going to put in this bucket is going to match with what our mount point is. And I've already got a role created, although if you haven't created one yet, you can use the auto generate function to quickly create an IAM role for this particular service. Now, we're going to configure the settings for this task. I like to give it a name. And what we want to do here is that we really only want to transfer the data that is changed. Because Data Sync does a verification for all the data and all the data integrity checks from point A to point B. So on Delta Syncs, we don't want to recheck for everything that's in the source and destination. We only want to check the data that has been transferred. Then there's many options within here. So we want to keep our ownership, keep our permissions, keep the timestamps in this particular case. And then for safety, we're going to keep files that have been deleted from the source in the destination. So even if you delete them on premises, we'll still have a copy in the cloud. You have the option to choose whether you'd like to do that or not, as well as some overwrite options. And we have the ability to set a bandwidth limit so that you don't use up your whole pipe. And in this particular case, what we're going to do is I'd like to exclude those htaccess files. So I'm going to add a pattern. Now you can add as many as you like here. And there's all sorts of syntax examples of things that you can exclude. Data Sync has the ability to do as aggressive as hourly or daily, weekly, etc. You can even do a custom schedule for the number of times that it actually runs. In our case, we're not going to do a scheduled job. We're going to do a one-time sync and a final Delta sync. And then I'm not going to add any tags for this, but depending on your organization's tagging policy, if you have one, you may want to refer to that. We also enable CloudWatch logging. So I've created a CloudWatch group and NFS file server migration. You may choose to organize however you like. Now we're going to review our settings and create task. Our task is now available. You can see that our source and our destination have been created. We can review the options that we set up. And we haven't obviously run the task yet. So I'm going to go ahead and hit start. Once again, you get to verify those options before you kick the job off. I'm going to say start. The task is now running, and we can review the status as it runs. All right, so on the history tab, we're able to view the status. Now that our job has completed, we have some statistics. If we click on the actual execution, you can see there are 305 files transferred. That's files and folders. You can see the throughput. And again, a review of everything that we had, as well as logging. And if we go to our S3 bucket, we can go and view that folder structure that we just created, just synced. And it's that same project 1, 2, 3 with the 100 files each, except these are now all objects. Okay, so now that our data is been copied to S3, our next step is to create a share on our file gateway that exposes this same data set to our NFS client, where we can mount this share from our file gateway and see the same data in the new location. So if we go to our AWS Storage Gateway, a few things to note. It's got a name, it's got a time zone, the status, all sorts of information, but more importantly, our VMware HA status has been verified. So we actually validate that your HA setup is working, and you can test that at any time. And for our purposes today, we're going to choose our storage gateway, and we're going to create a file share. We're going to input the S3 bucket that we sent the data to previously. We're going to choose NFS, although you always could do an SMB. Each file gateway supports up to 10 shares and can also support both NFS or SMB. We'll review our settings. In this case, I'm going to create a new IAM role and say next. Now for this demo, rather than it being wide open to all clients, I'm going to limit my availability to my local subnet. Leave the defaults for permissions. Okay, now that our share has been created, we can see all of the information about our share, including that allowed client list, root squash or no root squash, the actual export path, which is being served off of our local on-premises virtual machine for Storage Gateway. We have monitoring set up, and we have the mount options for all of our operating system versions. Okay, so now we're going to go to our NFS client, and we're going to mount the share that we just created. And it's that same mount command that we saw in the console. I'm going to specifically mount the data folder, and I'm going to mount it to mount storage gateway data on my local machine. So we can now see I've got both the source location and I've got the destination location for our migration scenario. And let's go take a look at the data inside of that. Should be the same folder structure. And it's those same 100 files. So now at this point, we've actually copied all the data from the source to the location using AWS Data Sync. We've now created a new share from Storage Gateway, mounted that on our NFS client, which is our application server in this case. We've verified that the data is there, and if you notice, there is no htaccess files, so the exclude operation did work. And we'll treat this as our initial sync. Now, we're going to change some files as if some period of time has elapsed, and then we'll rerun the data sync task and verify that those changes have synced over. So while in this project one folder, I'm going to touch new file 01, new file 02, new file 03. We've now got 3 new files in our directory. Because we've already created the AWS Data Sync task with the source and destination, we can simply go to our tasks, use that same task that we've already created, and simply start it again. All right, so now that our job has completed, we can dive into the task itself, and we can see that 4 files have been transferred. So that's 3 files plus the folder that had modified timestamp changed as well. Now, before our file gateway can realize these changes in our S3 bucket, we have to do what's called a refresh cache, which will update the metadata inside of that file gateway virtual machine to let it know about the new data that has changed in the S3 bucket. So we're going to go back to Storage Gateway. We're going to select our file share, go to Actions, and refresh cache. We're going to hit Start. Okay, so that process is now taking place. And we're going to go back to our NFS client. All right, now that our refresh cache task has completed, let's go back to our NFS client where we can see the Storage Gateway file share as it was previously. And we can do a before and after. So you can see our 3 new files have been copied. In our simulation, this is the time for the actual cutover. So we'll proceed with actually unmounting that old NFS file share and consider this complete. At this point, all of our applications would be redirected to our new Storage Gateway location. If I wanted to, I could actually go in and shut down my NFS server as long as no other systems are accessing it. And we have completed the file server migration. So to review, we have actually completed a migration from an on-premises NFS server to data that is stored in Amazon S3 with AWS Data Sync. We have validated NFS access to Amazon S3 from AWS File Gateway and shut down the on-premises NFS server. In step 1, we set up a data sync task to sync data from on-premises to S3. In step 2, we created a share in File Gateway and were able to access the X3 data via NFS. In step 3, we performed an incremental transfer of only the change data and ran a refresh cache task on the file share in Storage Gateway to make sure that that data and metadata was updated. And then in step 4, we verified that that data did come over with that Delta Sync, and we were able to unmount our on-premises NFS system. Also in this talk, we discussed the cloud adoption journey and many of the challenges associated with it. We also discussed our AWS Storage Gateway and reviewed a real-world customer example who leveraged AWS Storage Gateway and AWS Data Sync to shift from on-premises NAS to cloud storage. We discussed AWS Data Sync as a migration tool and learned about the different AWS in-cloud and hybrid cloud storage services available today. And then lastly, we demoed how one might perform an NFS file server migration using AWS Storage Gateway and AWS Data Sync to migrate to cloud storage. We appreciate you taking the time to sit in with us today. If you'd like to learn more about any of the services that we covered or try it out for yourself, we have a number of links. You can go on the AWS Data Sync, Storage Gateway, S3, EFS, FSX for Windows File Server, or a GitHub workshop that you are able to run on your own Amazon EC2 instances and CloudFormation scripts to actually try this out for yourself. Thank you everyone for joining us today. We really appreciate your time, and I hope you learned something. We now move on to our Q&A session via our live chat, and thank you all for participating.